Hey everyone, welcome back to Quesadilla Math with me, Mr. Padilla. Today we are going to be talking about functions and how they're different from relations. What is the definition of a function? How can we tell them apart? Let's find out. So let's start off by talking about relations. A relation is any set of inputs and outputs. That's pretty much it. It's a very simple definition. A relation, any set of inputs and outputs. Now, when those inputs are related to outputs, we can consider them an ordered pair. An input and output relationship, an ordered pair. And we can represent ordered pairs in a lot of ways. You have coordinates, which we also call ordered pairs, tables, graphs, mappings, and equations. All these different ways we're going to use to represent relations, look at different relations. So relations aren't any specific thing. Like I said, they're just a collection of inputs and outputs. So let's go into a certain type of relation now that we're really going to be dealing with all throughout Algebra 2. So now let's talk about a specific type of relation that's called a function. Not every relation is a function, but every function is a relation. A lot like not every rectangle is a square, but every square is a rectangle. So even though relations are made of inputs and outputs just like functions, there is a specific definition for a function that we have to consider. So a function is a relation where every input has only one unique output according to some rule that relates them together. The set of inputs we call the domain, and their related outputs we call the range. You guys might be familiar with this from the last video. The domain are typically represented by the variable x, and the range we refer to as y value. In a function, x's have only one output. A relation, x's can have different outputs for the same x value. So the way I like to think about functions is like this. You can't have cheating x's in order to have a functional relationship. There's only one y for every x. However, as we'll see later in this video, that's not true for the y values. So let's dig a little bit deeper into what a function is. So one of my favorite ways to think about a function is the analogy of the function machine. Okay, now when I think of a function machine, what I really think of is kind of like a vending machine. Here I am vending some fancy function cola. So using our vending machine as an example, we can kind of compare the way it works to that of a function. So just like a function, a vending machine has inputs and outputs. Inputs would be the buttons that you press. The output would be your soda, your fancy function cola. Of course, for a vending machine to work properly, when you hit a certain button, you should expect a certain product to come out. For example, if I were to select a nice -1, I would expect to get, for example, a +3. However, if I were to press the 5 button, this time I would expect to get a 19. So this is all fine and good, but let's say you really had a hankering for that -1 cola again. So if you hit that -1 again, you should reasonably expect to get the same thing out, another 3. That's how you can tell that this fancy function cola machine is actually working. The machine is working properly. I would say that's functional, wouldn't you? But now let's consider what would not be a functioning soda machine and therefore not be a function. Okay, let's say you press that -1 button again for your favorite cola, but this time you get a 6. And you say, well, that's strange. So you put in some more money, you click that -1, and this time you get an 11. Well, what's going on here? This machine's not working. It is not functional. So this would not be a function. So now that we have a basic understanding of functions, let's go ahead and look at a few examples to get some better clarity and really learn how to tell the difference between a function and a non-function. So our first example will be a relation in the form of a graph. And our job is to tell if this relation is a function or if it's a non-function. Now, when we're looking at graphs, there's a very simple way for us to be able to tell if a graph is a function or not. And that is the vertical line test. So the vertical line test allows us to find out if every input value has its own unique and only one y value. The idea is this: if you take a vertical line and you draw it on your graph through any or every point of your relation, and it only goes through once, that means we have a function. If a vertical line touches the graph in more than one place, it is not a function. So here I can show you guys this way. If I go to this coordinate right here, which is -1, 2, no problem, it only goes through one point. So far, looks like we might have a function. However, if I go ahead and I test these points here, I notice that my vertical line is actually crossing both points. Now, if we look a little bit closer, you can see that both of these points share an x value too, but they're related to two different y values. That's no good. That's what we call a cheating x. So this is not a functional relationship. In fact, there are a couple of other points that are in having the same problem here. Here I have 8 and -2 and 8, 8. Again, the same input value with two different output values. So it fails the vertical line test. So this is not a function. So let's test this out on a different graph. This time, let's look at this collection of points and let's test out and see if this is a function. So I can go ahead and draw a line through each of these coordinate points, and at no point does this vertical line touch more than one coordinate at a time. If we look at each of the coordinates, you can actually see that each input value only has one output value. There are no cheating x's here, so this is a functional relationship. So now let's compare this pair of relations. Starting with this pink graph, I can also use the vertical line test on not just a collection of points, but a full-fledged curve here. And as you can see, no matter where I cross my vertical line, it's only ever intersecting with one point at a time on this particular graph. However, if I look at the blue relation over here, you'll notice that it crosses in more than one place. So this vertical line is touching the graph at 2.14 and 1.068 and 2.14 and -1.068. So clearly we have a cheating x. So our blue relation here is a non-function, and our pink relation appears to be a function. So let's look at some other representations of relations and how to determine whether they are functions or not. So this is a representation of a relation that's known as a mapping. It works a lot very similarly to tables and coordinate pairs. It simply just tells you in a different way what input values, what domain values are related to which range values. So in this case, you can tell they're related because of the arrows. -5 is related to -2, 0 with 1, 1 with 6, and 3 with 1. So in this case, this would actually be considered a function. As you can tell, every single domain value, every x value, only has one y value that it's paired to. Now you might wonder, oh well, what about this y value here? This y value is cheating. It has 0 that's paired with it and 3. This is okay. This is allowed in function rules. The only thing that cannot have more than one value associated with it is a single x value. So let's see what the other side looks like. So this relation, this mapping, shows us an example of a non-function. So this is a non-function because in this case you can see that the input value of 2 is paired with 2 output values. This domain value has 2 range values, which is not allowed in a function. that's a cheating X. It's not allowed. So when you're looking at a mapping, the key is to look for any input values that have more than one line sticking out from them. Okay? That is the key to a functional relationship. Of course, I'm only talking about math here. Takes a little bit more for other kinds of functional relationships to happen. But I digress. Let's go ahead and look at a couple more ways of representing functions and relations and how to tell a function from a non-function. So when you're looking at relations that are being described in a table or as a collection of coordinate pairs, the key to understanding the function and non-function is the same as it has been for the last couple of representations. The same x value cannot have two different y values. Now, I hear from over my years of teaching, I've heard a lot of students tell me that they can tell a non-function because of repeating x's. And this is something that I want to try to banish from your mind, because it's not so much about repeating x's. Functions can have x's that repeat. It just has to have the same y value associated. So for example, if we look at our function example, you can see that we have -3 paired with 1 at the beginning of the table. Now, ordinarily, you would think, oh, look, there's another -3. This is not a function. But if you notice, they have the same y value. So it's really just a repeat of that coordinate, and it isn't breaking functionality rules. So this is a-okay. Now, what is not alright is, let's say we had the same type of function, but this time -3 is paired with 1 at the beginning, and -3 is paired with 5 later on. This is unacceptable for a function. The same domain value cannot have two or more different y values. It can only have one. So now let's look at some real-life situations that can be modeled by relations and determine whether these situations could be functions or non-functions. So in our first example, we have a relation where a person's height is the input and the person's eye color is the output. Now, on its own, a situation can be kind of difficult to gauge whether or not it's a functional relationship or not. So sometimes it's useful to imagine you putting it in a different format. So for this example, I listed some different heights and different eye colors in ordered pairs as coordinate pairs. And what I discovered is that it is possible to potentially have someone who is 5'8" and have blue eyes, and another person could be 5'8" and have brown eyes. So because the same input has potentially two different outputs, this situation would not be considered a function. Now let's look at our B example. Our B example says a relation where a student's school ID is the input and their shoe size is the output. So I know that none of these things really have anything to do with each other, but even in this situation, since every student has their own unique ID, it doesn't make any sense for there to be an X value with two different Y values. Most people have the same shoe size as themselves. So in this case, I chose to represent it with a little graph. And as you can see, even though everybody's shoe size may vary, since no two students share the same ID, there can't be the same input with two different outputs. You can think of it again as being able to pass the vertical line test. No matter where a vertical line crosses through a graph like this, it would not touch any point more than once. So that is how we can judge situations as functional or not. So thank you for joining me for our little introduction to what functions are. In the next few videos, we're going to dive deeper into functions, learn how to use function notation, learn how to graph different types of functions, and really begin our year-long study of the different types of algebraic functions that you'll find in Algebra 2. So I hope you guys got a little bit of something out of this today. If you could please give me a like and subscribe, I will be eternally grateful. And you might have some extra resources to help you in your Algebra 2 journey. So as always, I'll math you later.